In India, most industrial projects fail before construction even begins. The problems start during planning, when ideas and assumptions are not properly tested. As a result, many large capital projects exceed their budgets, often by 30% or more. Regulatory hurdles and land-related challenges further worsen these cost overruns.
A feasibility study reduces this risk before ground is ever broken. It exists to answer one question: should this project be built here, now, at this scale, and within this budget? Manufacturers who skip this question usually pay for it later at a far higher cost.
Every manufacturing plant rests on a set of technical assumptions. Soil conditions, utility supply, and technology performance all have to work as planned. If those assumptions are wrong, the project cost grows fast.
Skipping a geotechnical survey is one of the most common early mistakes. Projects that proceed without one often see civil costs rise by 10 to 30%. Power is another blind spot. Grid capacity and connection timelines vary by cluster. Discovering that the power grid cannot support the project after buying land can be expensive. For a factory, this also means estimating water, steam, and compressed air requirements correctly.
Technology choice carries a similar risk. It has to be benchmarked, not assumed.
That often means equipment that works well abroad but not in Indian conditions, or a technology designed for a level of demand and automation that never materializes, or equipment without local spare parts and technical support to keep it running. Correcting the technology choice is cheapest at the feasibility stage. The same correction at the detailed design stage costs 10 times more. Made after construction has started, it costs 100 times more.
Capital cost estimates also come in two forms. A rough benchmark is not the same as a detailed budget built from the ground up.
Projects that rely on rough benchmarks routinely see overruns of 20 to 40%. In contrast, a bottom up estimate calculates costs for the actual site work, equipment, and project management fees. It also stress tests those numbers the way lenders and boards expect it to. It examines what happens if steel prices rise by 15% or the schedule slips by 6 months. It also assesses the potential impact on returns if demand falls below assumptions. Manufacturers need those answers before a lender or board signs off, not after.
The paperwork carries its own timeline risk. Environmental and pollution control approvals are rarely as fast as promoters assume.
An environmental impact assessment alone can take 6 to 18 months to complete. Consent from the State Pollution Control Board can add another 12 to 24 months. None of that is a delay if it is planned for at the feasibility stage. It only becomes a delay when it is discovered after construction has already started.
The consequences are not theoretical. This same pattern repeats across Indian manufacturing projects.
One manufacturer built a new plant sized to an optimistic 5-year growth forecast. No feasibility study was commissioned. Construction went ahead on the promoter's own numbers. By the time the plant opened, a competitor had entered and raw material costs had risen. The plant ran at 40% utilization for its first 3 years. It could not service its own debt at that level of output. Skipping the feasibility study saved half a percent of the budget initially, but it ultimately cost the company the entire project.
A feasibility study is not a delay before construction. It is what makes construction safe to start. It protects capital, sets realistic timelines, and gives lenders a case they can trust. If your company is planning a new plant or expansion in India, IMARC Engineering can help. Let's discuss your project before the first rupee of capital is committed.